If you're interested in astronomy and SETI, the search for extraterrestrial intelligence, you know the name Frank Drake. And when you meet someone like that, one of your heroes, it's a special moment. And he did not disappoint. So if I'd have asked you back in the 1960s, by the 21st century, do you expect to have seen a signal? What would you have said?
I would have said, yes, I expect to succeed, because we were doing a lot of searching then.
Does that make you disappointed?
I'm disappointed, yes, but not surprised. What we've learned over the years is that the searching has to be much more comprehensive than we realized 50 years ago. But we know it's still doable. It just takes much more time than we imagined. Let me show you something. This is an orchid, a very peculiar and beautiful orchid. It's very fragrant, which actually only blooms 2 days a year. If you had been here 2 days ago, you wouldn't have seen this orchid, and you might have thought that this plant never blooms. Well, so it is with SETI. We've learned that we must search over and over and over through the years till we are in the right place at the right time to make the discovery.
What are they called?
This is called a stanhopea. It has hope in its name, and we have hope that someday we'll be in the right place at the right time in SETI.
Frank Drake makes the argument that if there are civilizations out there, then you might imagine that the radio waves that they send out are passing through the galaxy. And so they would be passing through this room now. So if only you had a sensitive enough detector, then maybe you could pick up the signals. And he's right. The point he's making it as a scientist is that the only way you're going to know is to look. And he doesn't think we've looked closely enough. And I agree with him. But Frank wasn't content just to hang on the line, waiting for ET's call. In 1961, he devised what remains a useful scientific framework for considering how likely it is that we share the galaxy with others. The Drake equation has become famous because it gives us a tool to continue the search. It dares us to answer a series of provocative scientific questions. And on the left-hand side, there's the number we want to measure, the number of intelligent civilizations in the galaxy that we can communicate with. And then there's this group of terms that really ask questions about ourselves. How likely is it for life to arise on a planet? How special is the Earth? How special is the Sun? How special is the solar system? How special is intelligence? And then there's this last term, L, which perhaps speaks to us most profoundly of all, the lifetime of intelligent civilizations. Do civilizations live for a long or short time? And if it's short, what is it that destroys them? Is it a natural disaster? We do, after all, live in a violent universe. Or are they condemned to destroy themselves? When Frank first thought about it, sort of 50 years ago, for example, the number of planets around distant stars, how likely is it? What's the probability that a star will have planets around it? We didn't know. We hadn't detected any. It's not till the 1990s that we have the evidence for planets around different distant stars. Now we have dedicated missions to go and look for them. And these missions are revealing a universe full of possibilities. And in the constellation of Pegasus, around a sun-like star, there's a planet called Osiris. It's way closer to its parent star than Mercury is to our sun, but it's a massive gas giant, a hot Jupiter. And by measuring the light that shines through its atmosphere, we found that the atmosphere is full of hydrogen and methane and water. And just 24 light years away in the constellation of Scorpius, there's a small rocky world, one of the most Earth-like worlds we know. It orbits around a red dwarf star, which is one of 3 stars in the system. A planet with 3 suns in the sky.